Hello everyone, and welcome again to another series in CPD in 43. Today we have Jon Parsons from Recticel, who will be doing a presentation on managing thermal performance. Thank you to Jon for coming along today. As usual, we will have his presentation, which will then be followed by a Q&A session. If you can please ask any questions in the chat box, which we can then field to him at the end. We will also give you an update on the rest of the calendar for the year towards the end of the presentation, just so you have an idea of the events that we've arranged for the remainder of the year. So without further ado, I will hand it straight over to Jon. And yeah, if you have any queries, please field them in the chat box.
Good afternoon, everyone. I'm just going to load up the presentation now. Just bear with me a second. It's going to take 30 seconds and then we'll be in. Right. If one or some of you are able, if you can just give me a quick thumbs up or just maybe type a quick message into the chat room just so I know that you can see the presentation. All good. Excellent. Thank you very much. Right. Thank you very much for my introduction. I'm just got a couple of things on the screen, which I'm just trying to get rid of. There we go. Much better. So yeah, thank you for the introduction. So my name's Jon Parsons. I'm going to try and follow these slides as we go. So this is me, Jon Parsons, Specification and Housebuilding Manager for Recticel and for Gradient. There's two sides to our companies. I'll explain more in the next couple of slides. So the Recticel Group, we're actually Europe's largest manufacturer of PIR products. So when I'm talking about PIR, it's hopefully you can all see me, it's the foam that's within these insulation products. Now, often when I'm doing these live presentations, I do like to ask the question, what does PIR stand for? But if you just want to have a quick think, and I'll come back to that one in a second. So PIR, that's the product that we manufacture, but depending on the facings of the board, that's what makes them suitable for different applications. Now, Recticel's route to market, we don't go straight through. Oh, really apologise. My front doorbell is really sorry. Really sorry, very unprofessional. Right, you can always rely on the Amazon delivery to turn up exactly the moment that the presentation starts. Right, let me just compose myself again. So, Recticel, Europe's largest manufacturer of PIR products, and we've got the largest presence of PIR products in the UK, so we're a very established company. Now, our route to market is through merchants and distribution. If you specify a Recticel product, your contractors can pick them up via, say, Jewson's, Travis Perkins. On the merchant side and distribution-wise, SIG, Minster, CCF, Encon, Galaxy, Markowitz. We've got plenty of distributors and merchants out there stocking and supplying our products. Now, as I mentioned before, PIR, it stands for polyisocyanurate. And for that reason, we're still going to refer to it as PIR because it rolls off the tongue a little bit better than polyisocyanurate. One thing I did mention, so Recticel manufactures flat insulation. And as I mentioned, we've got a sister company called Gradient. So if any of you guys get involved in tapered roofing, this is exactly what Gradient does. Gradient have been doing this since 1985. Now, Recticel, we only came across to the UK in 2008. First thing we did was to acquire Gradient. So Recticel manufactures flat products. What Gradient does is cut to full schemes. So if anyone out there is designing tapered or designing buildings where they want to put tapered insulation, it allows you to build the deck completely flat. And what Gradient does, they cut a full in that insulation. We've got plenty of system partners that use our products and use our design. So, for example, in the background, let's say you're familiar with Sika or Langley's, Carlisle, Renalit, Polyroof, Kemper, Denosa, Albitra, put myself on the spot here, Triflex, Alimask, all of these companies It'd be Gradient doing the designs, and it'd be a Recticel insulation used within that tapered waterproofing flat roof system. Right. So what we're going to do today, we're going to look at U-value calcs and condensation risk. Just going to sip on a coffee. So here you can see we've got some thermal imaging of a house. It's very residential led, this presentation, but regardless of whether you're building sort of residential buildings like this or more commercial, the theory and the practice would be the same. So looking at this thermal imaging, it gives you an indication of where the heat has been well retained, like the roof, for example, is very well insulated. But as you can see, heat is being lost through the windows, the door, the chimney breast, eaves, etc. Different difficult places to insulate. Now, as I've mentioned, what we manufacture is PIR. And what does PIR stand for? Let's have a little think. Now, there's plenty of other products out there which insulate, as well as polyisocyanurate. Sorry, can't see slides. Usman, are you able just to come back in? A couple of people have said they can't see the slides.
Hi, John. I wouldn't worry about that. Paul, if you could maybe just log out, log back in. It might be an isolated issue. I can see them. I hope everyone else can. Can you please respond in the
We can
chat
get a
box
few
if
thumbs
so?
up just to check. All good. Okay. Right, wonderful. So I'll carry on. Hopefully Paul can log back in and join us. Maybe you can see the recording if he misses a bit. So as I've mentioned, again, we manufacture PIR, very efficient when it comes to retaining heat, thermal conductivity, etc. But depending on which area of the building you're looking to insulate could depend on which product you want to use. Let's say cost is your main concern. Then maybe a mineral fibre, a glass mineral wool of some sort would be a very good option. Let's say you're insulating the loft of a building at ceiling height. Maybe you've got loads of space. Space doesn't matter, but cost is your main concern. Then that could be a good option. But on the flip side of that, if space is a concern, and you do have height restrictions, often this product here would get used. Maybe you're working on a building, you've got a lovely one-off property, you've got some doors that open up from the lounge, or maybe on a first floor or a bedroom which open up onto a roof terrace. Now, the building regs are forever increasing, so now we might well be looking at sort of 200 mm of insulation to hit the required U values. I'm not sure if you're familiar with a vacuum insulation panel. Now, let's say we've got a mineral fibre here, and this much reaches the required U value. Potentially, you might need that much of PIR to do the same job. Now, this DEC VQ panel, which is our vacuum insulated panel, potentially you might need that much. So these three thicknesses of product potentially could achieve the same U value. So if you, as I said, if you're working on, let's say, a roof terrace and you want to open up your doors, you don't necessarily want a 200 mm step. 105 mm of this would do the same job. Quick rule of thumb, roughly half of this will achieve the same as a standard PIR. Now, the core of this product has got a lambda value of 0.006, whereas this has got a lambda value of 0.022. Certain glass minerals might have a lambda value of 0.044. So very, very thermally efficient product. Again, please contact me after. I don't want to go into too much detail about these products now because obviously we've got a presentation to run through, but I'm more than happy to come back. Contact me directly, please, and then we can either have a chat, we can do a Teams call, we can just send each other emails, whatever we need to do. But I've got brochures and documents and data sheets on all the products that we manufacture. Again, depending on which product you're looking for, maybe you're looking for a product with a really good compressive strength. Maybe you're doing a car park floor or something. So maybe then you'd be looking at a polystyrene-based product. A typical KPA of a PIR product would be about 150. Polystyrene-based products can be anything from sort of 300 to 700. So again, just making sure that you use the right insulation for the right application. So why do we insulate buildings? I think there's a lot of people on site who haven't got a true understanding of why we're putting the insulation in, because the insulation does need to be put in correctly for it to perform correctly. It's a very important part of the build, and also it's a very expensive part of the build. So it makes sense to put the products in correctly. Now, obviously, these two products here, if they're going together, they need to be buttered up. They need to be nice and tight in order for it to work properly. Otherwise, it's like buying yourself a really expensive snowboard jacket, getting to the top of the mountain, questioning why you're still cold, and then looking down, realizing your zip's undone, zipping it up, putting your hood up. Oh, that works better. If the building isn't wrapped up, these three key points actually are worth remembering. This will improve the energy efficiency of any build. Continuous insulation, reducing thermal bridging, and improving air tightness. Them three key points, regardless of whether you're just insulating a little outhouse in your garden, building a house, building a commercial building, continuous insulation, reducing thermal bridging, improving air tightness will improve the energy efficiency of any build. Now, if we sort of go back to basics and look how heat actually moves, you've got conduction. Well, let's start with convection actually. So how heat rises, so the importance of insulating the roof or the loft of a building. We've got then conduction as well. Sorry, my eyes have gone a bit funny. And conduction, that's what we're going to look at in more detail, because different building fabrics on site have different conductivity, and it's very important that where products such as steel are used with a very good conductivity, that the detailing's done round so we can sort of box them off and separate them from the rest of the build. Otherwise, you can create a lot of thermal bridging. Now, thermal conductivity, sometimes known as K value, more often than not now known as lambda value, is measured in watts per degree Kelvin. And basically what we're doing, we're looking at the temperature difference between one side of the material through a meter and the temperature difference on the other side. So it's temperature difference between one side through a meter compared to the other side. And again, it's measured in watts per degree Kelvin. Now, again, a quick rule of thumb for lambda values, U values, psi values, the lower, the slower. The lower the lambda, the slower the heat's going to pass through that product. The lower the U value, the slower the heat is going to pass through that build-up, through that system. If we look at steel, for example, now I've mentioned that a standard PIR, like this, a foil-faced PIR has got a lambda value of 0.022. If we look at steel, steel's got a lambda value of 50. Massive difference. Steel is a very poor insulator, but a very good conductor. Also looking at different areas of the build, if we look at, let's say, the block work, then let's say you've done your calculations and the U value, maybe you're trying to achieve a 0.18 U value. Maybe you've actually only achieved the 0.19. Potentially, if you use the dense concrete block, which has got a lambda of 1.2, if you were to change that to a lightweight block, which might have a lambda of 0.15, then that might just tweak it and put you over the line, and then you might achieve a 0.18. So there's little subtle changes you can do with the build if you're just marginally out with the U values. Now, the resistance varies because the U value, actually, what thing I didn't say, looking at lambda value, let's say you had 50 mil of product, that would have the same lambda as 100 mil, that would have the same lambda as 150 mil. So the lambda would stay the same. The resistance, however, varies. For example, this would have more resistance than this. So because it varies, there needs to be a calculation. If we had 110 mil of PIR with a lambda of what we now know would be 0.022, you would do 0.11 divided by the 0.022, and that would give you a resistance of 5. Working with that resistance of 5 and comparing it to different building fabrics on site, if you wanted to get the same resistance as you would get with 110 mil of PIR with block work, you would need about 6 meters worth of block. Or maybe a bit more relevant, because we only have to think back 100 years and we were building houses out of solid brick, you would actually need nearly 4 meters worth of brick to give you the same lambda as, same resistance, sorry, as 110 mil of PIR. And unless we're going to go back and start designing castles again, we need to be looking at the insulation. Timber, you'd need about 6 times as much timber and about twice as much mineral wool to give you the same lambda, or same, sorry, resistance as 110 PIR. Actually, if this was flipped on its side, it'd be a nice little graph, just so you can actually see the difference in the resistance of the properties that I've mentioned, products that I've mentioned. Now, looking at thermal bridging again. Now, as we've just looked, we know that timber will lose heat about 6 times faster than PIR. And when you get a timber frame house, let's say this is the timber in the centre, roughly 15% of a timber frame house is timber. So that's 15% of the house losing heat 6 times quicker than the rest of it. So either that needs to be calculated, or B, attention to detail. Maybe what you could do, if you have done that sort of design, you could then get some insulated plasterboard, run that across the front of the studs, and then that way you're going to have continuous insulation, you're going to reduce the thermal bridging, and you're going to improve the air tightness. So then 3 key points I've just touched on are going to be worked on if you do that attention to detail with the insulated plasterboard. Now somehow on my screen is so small. I just need to adjust this slightly, because there we go, I can read it now. So let's say we had 140 mil PIR between the studs, then that 140 mil PIR would have a resistance of 6.35. It should say it's somewhere here, yeah, 6.35. Taking into account that the thermal bridging that them timber studs are doing, actually that 6.35 would quickly reduce down to 5.55, meaning there'd be an overall reduction of 12% within that build if the attention to detail, like continuous insulation on the outside of them studs, you would need to allow for a 10% reduction. So obviously that house wouldn't perform as well as it potentially could without reducing that thermal bridging. Just going to let you have a quick read through that section there, what we've just covered, whilst I have another sip of my coffee. If anyone does have any questions throughout the presentation, please drop them in, and if I can build them into the presentation, I will. It's very strange for me just not having I'll try and keep my presentations as interactive as possible, so this is a slightly different format for me. So moving on to section 2. So once we've looked at the resistances and the lambda values, we're now going to look at how you arrive at the U value. So working with your resistances, going from the inside to the out, what you would do is mark down all your resistances. So the plasterboard, the dabs. Yes, no problems at all. I can forward you a PDF of this presentation afterwards. You just contact me afterwards and I can get anything sent out to you guys. Oh, we've got somebody else who can't see the slides as well. Okay, all good. Hopefully it's just 1 or 2 people that can't see. Maybe if you log out, log back in, hopefully we can. Yeah, we've got a few people dropping out here. Hopefully you can log out, log back in, and hopefully we can carry on. But yes, I can send this out to anybody who contacts me. So once we know all our resistances, to get to the U value, we add up all the resistances. So it'd be the resistance of the plasterboard, the dabs, the block work, the mortar joints, the insulation, the cavity, the brickwork, the mortar joints again. And then you'd add up all them resistances, giving you the RT, the resistance total. And then the U value is simply 1 divided by the resistance total. Now, this always used to be done longhand, but fortunately now there's software in place, and providing you give ourselves, Kingspan, Celotex, whoever your sort of go-to is, hopefully after this presentation, a few more of you will be using Recticel, but we all use the same method here, which you can see in this section. So providing you give us all the same information, you will get the same information back. One thing I'm just going to quickly touch on now, a build up like this would be one of our calculations for here. And if we do look at this picture here, because it's a cavity wall, brick and block, there's going to be wall ties going across. Now, wall ties tend to be stainless steel, and any heat generated in this room is going to be transferred across that wall tie, because as we know, stainless steel and steel is a very good conductor. So that would be calculated in this section here of one of our U value calcs. Also, within a brick wall, mortar joints lose heat quicker than brick, and 17.5% of that brick wall is mortar, and about 6.5% of the block work wall is mortar. So there's more heat being lost through the mortar joints than there is through the wall. Also, a wall like we've just looked at would give you a U value of a 0.28. But if I just go back to that slide, obviously now we should be trying to achieve a 0.18 within a wall. So potentially, if you wanted to stick to this same design of a 100mm block, 100mm cavity, 100mm brick, so an overall width of a 300mm wall, rather than changing the design, you could just change the specification. So rather than going down a partial fill route, like you can see here, where you've got 50mm insulation and a 50mm residual cavity, what you could do is use our Eurowall Plus product, which is a rigid full fill. And because it's got the tongue and groove on here, you no longer require a 50mm residual cavity. With ours, you've just got a 10mm. So that means you can then put 90mm product in a 100mm cavity. You've stuck to exactly the same design. All you've done is a specification change, and you can now achieve a 0.18 rather than a 0.28, just from a spec change rather than a design change. Now, I'm not sure how most of you do your U-value calcs. You might well use a SAP assessor, you might well have your own software, or quite possibly you go to one of the insulation manufacturers, ourselves, Kingspan, Celotex, one of the others out there as well. Now, with us, you've got two options. You've got the formal one, which is done in-house. And one thing I will say, the guys in our technical office are really responsive. I have heard horror stories from other manufacturers taking several days, if not a week or two, to get back to you just with a U-value calc. I'm going to put my neck on the line here, and I'm going to say to you guys that generally speaking, within a couple of hours, certainly within the same day, but generally within a couple of hours, you'll get your response from our guys. And a couple of the people in our technical office are also part of what's known as the BBA Competent Person Scheme, which means they've done a couple of exams, they're approved, they can give the correct information out to you guys. And just to keep them on their toes, by being part of the BBA Competent Person Scheme, it means that the BBA can pick up any of the info that we're giving you guys at any time, and they can double check it to make sure we're giving you the correct info. So before we send any info out, we'll check it, double check it before we send it. So rest assured it will be correct. And if you want details of project details, we could do that on the top of this, and also you can get a BBA stamp on the bottom of the, like a little certificate. We've also got a U-value calculator online, which is very easy to use. And what became clear to me straight away when I was doing this, sort of when I started this role about 6-7 years ago, was that about a third of architects that logged on to do a U-value calc logged off, because there was a requirement to put a username, a password, project details, client details. All I want to do is find out how much insulation I need to put in a cavity wall to achieve a 0.18. So all of that information I've just mentioned, there's no requirement. You don't need to remember a username. You don't need to remember a password. Don't need client details. Don't need project details. As soon as you log on, you go straight into the heart of the calculation, and it's really quick and easy to do. And once you've used it once, honestly, within 30 seconds, maximum of a minute, if you've bookmarked it, you can then go straight in and you can do another calc. Really, really easy to use. You factor in project locations. When we're doing condensation risks and things, we do look at where the project would be. So, for example, it might be different if it's based in Scotland compared to sort of London, but the U values, I think, are pretty much the same, but certainly condensation risks can change. Just finishing off my coffee whilst you catch up on section 2. I really don't like cold coffee. Right, section 3. So ventilation and insulation need to go hand in hand, because what you're doing when you very well insulate a building with continuous insulation, reducing thermal bridging, improving air tightness, is you're retaining the heat that you've paid for. And in turn, you're making the air within that building warmer. The only issue with warm air, though, the warmer the air, the more moisture it can hold. And potentially, if you haven't got very good ventilation, what happens then? Let's say this is your window. The window might not be as warm as the walls. So as that air is sort of floating around, as it gets near the window, the temperature drops and drops, gets to what we know as the dew point. When the dew point's been hit, that moisture condenses, it lands on the surface as condensation, and potentially can be an issue. So with new builds, as we're wrapping them up with sort of in an airtight envelope, ventilation's absolute key. With older buildings, it's not so much of an issue because you've got lots of natural ventilation. You've got big open chimney breasts, you've got windows and doors that don't fit or shut properly. And the good thing about that is the moisture's carried out. The bad thing about that is so is the heat that you've paid for. So there needs to be a happy medium. So when we look at condensation, in my eyes, you get good condensation and bad condensation. Good condensation can be found on the outside of a beer glass or it might be a glass of Prosecco, or it might be just a fizzy pop out of the fridge. In my eyes, it'd be an extra cold Guinness, but that's just me. But the theory's exactly the same. Now that you've got your glass, you've got a cold liquid inside the glass, the outside of the glass can now be the dew point, and any moisture in the air, once it hits that dew point, condenses, and that's where you get the little droplets on the outside of the glass. Now, I realise I've got time restrictions, otherwise I'd quite happily sit here and look at this slide for a little while longer, but we're going to move all back to the classroom. Right, so as you can see now, completely different image. This quite possibly could be down to poor ventilation. What might have happened, maybe this room here, the door's been shut, the radiator's been left on, there's no ventilation, the windows are closed. Maybe there's a lintel running across which is poorly detailed. As that heat and moisture rises, it gets to the lintel, temperature drops, dew point, condensation. In turn, you're going to get mold issues. Also, it may be on a timber frame structure. Now, timber is air permeable, so that air if the detailing hasn't been done well on, let's say, a vapor controller, maybe the vapor controller has not even been put in, then that air is going to work its way into the timber. Somewhere within that timber is going to be the dew point, and that can lead to interstitial condensation, which is condensation working its way from the inside out. And unlike a lot of damp issues, by the time you can actually see the problem, a lot of the damage has already occurred. So a vapor controller is a physical barrier. It stops the moisture getting into the structure. And if detailed correctly, it also doubles up as an air tightness barrier as well. So let's say you had two walls where you had air tightness barriers or vapor controllers. Make sure they overlap, make sure they're taped, make sure they are kept nice and airtight. Now, I remember when I was about 18, 19, 2 or 3 years ago, maybe a little bit longer. Now, I used to be, I think the term back then was a sparky's mate, but I think the term now is electrician's labourer. And I'd quite often be walking around a building site looking like this with a drywall saw in one hand and a little map in the other. And what would probably happen to a wall like this, the plasterboard would get screwed straight onto the stud work, straight over that vapor controller. And then someone like me would come along with a drywall saw. And back then, 20 odd years ago, there was probably only one light switch and maybe two double sockets. And I would just get my drywall saw and just hack in maybe them 3 holes to put the sockets. But obviously then you've compromised the way that the vapor controller and the breather membrane and the air tightness barrier is working, because you've cut holes in it. But nowadays, you're probably going to have 3, 4 or 5 light switches. You're probably going to have, I don't know, 3, 4, maybe 5 double sockets. You're going to have air conditioning sockets. You're going to have data cable sockets. That wall potentially could be absolutely hacked into, and then it's not going to do the job of a vapor controller or as an air tightness barrier. So what you could do is drop little battens down, maybe even just 25, 40 mil battens, fix them onto these studs. That way, creating like a little void, put the plasterboard on that void. That way, someone like a younger version of myself could come across, hack into that wall as much as they like, tuck the cables down the back. That vapor controller has stayed intact, that air tightness is kept to a max, and it's going to work more efficiently. Obviously, then we need to look at, or whilst you're doing this, you need to be looking at ventilation. Could just get trickle vents above the windows. But what I'm sure we're going to see more of moving forward is mechanical ventilation units. Now, breather membranes, a vapor controller will go on the warm side and stop most of the moisture, but it's never going to stop all of it. And you would definitely on the outside, you'd put a breather membrane, because if you put 2 vapor controllers, potentially the moisture that got through this layer would then be trapped into that sort of structure and rot. Then the sort of rafters, what have you, would start to rot. By putting a breather membrane on the outside, a breather membrane's got thousands of tiny little holes, which are large enough to allow any of the moisture to escape, but the holes are small enough to stop any of the rain from getting back in. Now, as I mentioned at the beginning, we've got a sister company called Gradient. And between Recticel and Gradient, we're doing a lot of these calculations because we work heavily on the flat roofing side. Now, the only flat roof that the BBA will recommend is a warm flat roof. Now, a warm flat roof means that if this is the deck, that enough insulation is put on top of the deck. And what that means is then the condensation point is pushed to the outside of the structure and condensation is not a risk. It doesn't rely on workmanship. It doesn't require ventilation. It just means you need enough insulation on top of the deck, and that will create a very safe, reliable system. Now, looking at this, if we had a single ply membrane on top, 120 mil of insulation, a vapor control layer. Now, quick rule of thumb, the vapor control layer always goes on the warm side of the insulation. So the vapor control layer here would go underneath it. Then we've got a plywood deck, joist, and a plasterboard ceiling finish. Now in red, this red line here is predicted temperature, and in blue, we've got predicted dew point. Now the dew point is always relative to the humidity. So because we've got a vapor control layer going across here, that is going to stop most of the moisture. And you can see here the predicted dew point here is 15 degrees. But because we've got that vapor control layer, that knocks 10 degrees off it, which means then it's not until it gets down to 5 degrees where the dew point's likely to occur. So that's a very nice clear-cut design, very clear-cut picture. That's what we would recommend. That's what the BBA recommend. If you can, always goes for the warm insulation. If you go for a cold roof, where you're putting the insulation down maybe at ceiling level, then you'd need to put ventilation in. If you're doing a hybrid roof, we'll look at that in a second as well. Literally a second. So you can now see, I can see why people would be tempted to go for a hybrid roof, because let's say you've got a real thick layer of insulation and you're thinking, I don't really want that much insulation on top of the deck. Maybe I can just put some below the deck. If you look at this picture here, you've now got a completely different image. There's not as much insulation above the deck, so the deck is no longer as warm as it needs to be. The vapor control layer is now sandwiched between the insulation, and you can see there's a lot more moisture getting to the underside of the deck. Because the underside of the deck is now cooler than it should be, the underside of the deck is potentially now where the dew point would be. So that could lead to interstitial condensation. Now, it could be avoided if you have got height restrictions on top of this deck. Just to give you an idea, if you were to use this build-up and were to use our Deck VQ product, which is our vacuum insulated panel, potentially 60 mil of this product could achieve a 0.17 on top of a timber deck like this. Again, more than happy to talk more about that. I can arrange CPDs directly with you guys, or you can just ask me questions after this event. Going to have another sip of water whilst you finish up on section 3. Then we've just got one more slide before I hand you back to Usman. Right, so if we just have a quick overview then. So initially we looked at making sure you choose the correct insulation for the correct application. We looked at principles of heat transfer and thermal bridging. We looked at lambda values, R values and U values. We know that as warm moist air cools, it can hold less moisture and can lead to condensation on cooler surfaces. The correct positioning of vapor control layers, breather membranes according to basic principles, and calculation methods have limitations and use assumptions. Seek competency. So if you have got quite a complex build-up and you've used our online U-value calculator and you've still got questions, please forward me the information and I can get a more formal calculation done for you. Also, if you want a U-value calc done for the floor, we'd need to put a PA ratio, like a perimeter area ratio, put in as well. So please always do use me as your first point of contact. And if I can't answer the question myself, I can certainly go in-house back to our technical department and I can come back to you with a correct answer. And just for everyone, please design, specify would be wonderful, but more importantly, build with confidence. Thank you very much, everybody. What I'm going to do now is just stop sharing and I'm going to hand you back to Usman.
Thank you so much, John. If anyone has any questions, please feel free to ask them. But I know obviously John did try to answer some questions throughout the event as well. So, but please do feel free to field them. Um, I one big question is probably that I think would be good to ask is obviously Recticel have a number of insulative products. Can you just run through the sort of the range of products that you guys have? You've obviously shown a couple that you
Yep.
have there, but if you could just run through a couple of the examples of the various bits that you have and just give a little
Yeah.
brief explanation.
One really good thing with what Recticel have done and the way we work, we always look at the end user and just trying to make things simple for people to specify, for contractors to buy, for merchants to stock, etc. And one thing I would say is our GP product, our general purpose product, which is our foil face product like this, is suitable for 3 applications. So if you want to put a product in the floor, that would be our GP product. If you want to put a product in a framed wall, that would be our GP. And if you want to use a product in a pitched roof, that's our GP. So it's very good for a specification point of view because it's one product to remember for 3 main applications. It's then great when it goes down to a merchant or a distributor because it's one product, one main product for them to stock. And more importantly, when your contractors go to buy that product, all they have to do is stock one product in various sizes. So the GP product is certainly our most commonly sold product, which is Recticel GP. As I mentioned, we sort of specialise on flat roofing a little bit. We have got products obviously for all over the building envelope, but we have got where we specialise because of gradient is on the flat roofing market. Now I've mentioned it's all PIR, but we've got a bituminous baseboard like this. This could be for a torch on felt. You can heat up. That can be torched straight on and fully adhered straight onto a product like this. This is our Power Deck U. We've then got a tissue face board for a single ply and EPDM. You could put a carrier membrane, put an asphalt roof onto this one, but again for a flat roof. If you were to work with a liquid system, again, that could be a foil face board or even a mechanically fixed on a flat roof. That would be a foil face board. A couple of other products that I've mentioned as well, which I'll come back to. I think I've just seen one here. With your cavity full fill, do you need to tape or join, or does a profile it out? So yeah, so this is our rigid full fill. We're selling a lot of this product at the moment. A good key point, I would say one of my most common specification changes is probably against the Kingspan 106. Now, the main reason for that is the products don't need to be detailed. They don't need to be taped. So because you've got the tongue and groove, that is what stops the moisture from going through. If it was a flat face like this, like the Kingspan, you would then need to tape it. But ours, it's a full fill. If you put, actually, that you might want to make a quick note of this. You can put 90 mil in a 100 mil cavity and you can achieve a 0.18 U value. You could put a 115 product into a 125 cavity and you can achieve a 0.15 U value. Or you could put a 140 product into a 150 cavity and achieve a 0.13 U value. So if you're working with a mineral fibre, you're going to have to build with a 150 cavity anyway and only achieve a 0.18. Whereas again, you could change the spec, build with a 150 cavity, hit a 0.13. That way, if you've got a load of roof lights in a roof, you can offset it by over insulating the walls. Different ways of hitting sap calcs. That's our rigid full fill. And then going back to our Deck VQ product, again, a vacuum insulated panel. Now the core of this is what does all the work, but what we've done to try and make it more user friendly, because the core of this can't be pierced, it can't be cut. We've wrapped it up in PIR to make it like a photo frame to make it more user friendly, because we know contractors aren't as careful as they potentially could be on site. And we've put PIR above it and below it because now it's got a compressive strength of 150 kPa. So as soon as that's laid, it can be walked on, it can be worked on, and it's a great product if you've got height restrictions, you want to reduce the height.
Okay, we've got a question in from Michael asking about the vacuum panels you just shown. He's asked whether they're expensive and also whether how robust they are. Obviously, I think you've just answered the second part of that.
Yep. So regarding price, yes, they are dearer. But I think you would generally only use the product where you didn't have space for PIR. So as I said, roughly speaking, half the thickness of Deck VQ is going to give you the same U value and the same build-up as the PIR. It is about 2.5 times the price, but it varies depending on the project size. But again, it's a specification change. Otherwise, you're going to have to go back to the design and look at changing the design. And that could be a lot, the implication of cost could be a lot heavier. Generally, when this is used for a roof terrace, most of the designs that I'm working with might have a cost of maybe £3,000, £4,000 on PIR, but often that's offset against the £800,000-900,000 house. So it's minimal in comparison, and it's a very quick thing to do because you're not changing the design, you're just changing the specification. And again, aesthetically, it can look a lot more pleasing as well, because if you've got 200mm of insulation, 150mm joist, you're going to have a fascia running around, which is massive. Whereas if you can reduce that by 100mm straight away, aesthetically, it might look more pleasing to the eye as well.
Okay,
I did
great.
just see a quick message come up about the rigid ball fill regarding wall ties. Now, yes, like Blue Peter, I just so happen to have a wall tie here. So what you would do, where you've got the tongue, if you like, typically what you'd do is build up about 6 rows of block. You would then, sorry, I'm very animated. I feel like I've got to actually build things. It's just the way I work. I've worked on plenty of sites before getting involved in this. So typically you'd build up about 6 rows of block. You'd then put the insulation in. You would then get your trowel, which I haven't got, so I'm going to use a great big bit of card. You'd then get your trowel, run it across the tongue. You can then put your wall tie down into that gap that you've just created. You can then get another bit of insulation and put it on top. You've got your retaining disc, and that's going to hold it back nicely. And that would all go together quite nice and flush. Now, the reason for keeping our 10mm gap, now this is key for us because I know some of the others don't do it. I know the Extratherm product is a very good product. They brought theirs to market before us. But theirs fully fills the cavity. What we've done with ours is to leave a 10mm gap. Now, that 10mm gap is absolute key because let's say you've got your block work and then you put in some insulation. If then your brickie comes along, chances are they've got fatter fingers than me. If they want to drop that brick, you typically, when you work with a brickwork, you drop the corner of the brick and you roll it into position. You then get your trowel, tap the brick, mortar snots, and you move on to the next brick. If that insulation is fully filling that cavity, what's very difficult is to drop the brick and to actually roll it in because your fingertips are getting stuck. So what you have to do, you have to hold the brick slightly differently. You have to drop it down early, push the brick up against the insulation. Mortar snots, it's a mucky, messy way of working. That 10mm gap just allows you to drop it, roll it forward. You've got a little fingertip space here, gives you a bit of tolerance, which I like to call wiggle room because we're not building things out of Lego, everything's slightly different sized. So by doing that, you've just got a little bit of tolerance when you're working. You've got fingertip space, and it's a much quicker, easier, more efficient way to work. And it's absolute key that the builders, the brickies, like using this product because they're the people using it. We need to keep the end users happy.
Great. And on that point, we've got a question in from Ian regarding the full fill 10mm cavity. He's asking whether that changes regarding exposure, so obviously location.
Very good. But very, very good point. It was that Ian that you mentioned. Very good point, Ian. Yeah, you can't use the product in severe weather exposure zones. So areas, a lot of Scotland, West Wales, sort of Cornwall, areas like this, the product can't be used. I have got different people using it in different applications. I've got a surveyor actually. I've just put an article out coming out in a magazine because what this surveyor that I've been working with, he was a big fan of the tongue and groove. But what he lives up in North Devon. He lives in Braunton, lovely seaside coastal area to live. But again, you get that sort of harsh sideways driven rain. So what he's done, he's actually used it as a partial fill. He's done a great spec on his own property, 0.11 U value in the floor, walls and ceiling. We doubled up on GP doubled up on 80mm GP in the floor, doubled up on 100mm GP in the roof. And what we did within the cavity, we used 115mm of this, but we used it as a partial fill, still with a 50mm residual cavity. And then on the inner wall, we put 40mm of insulated plasterboard. And when the building control inspector came out to have a look, They were just like, this is brilliant because you've got the best of both worlds. Not only have you got the 50 mil residual cavity, but you've got the tongue and groove as well. So absolutely, he was key, but different ways of working, get the building control involved if you need to. I have had it signed off before as well, just from people putting a waterproof render on the outside. But what the BBA states is that you cannot use it in severe weather exposure zones. But obviously, depending on if you're putting a waterproof render on the outside, you can then ask them if that would be acceptable. But always speak to building control or the inspector if you need to.
Great. We've got a question in from Stephen asking about the environmental credentials of the products, whether the materials are reused, recycled, end of life planning, etc.
I think the good thing about the PIR, it will outlast the life of any building. So if you've got a house which is going to be up for 70, 80, 90 years, it's going to last as long as the house and longer. So what it does in that time is obviously fantastic because it keeps that heat, retains the heat really efficiently. The products can't be broken down, can't be reused. Yeah, I suppose you could reuse them if you literally pulled down the brick and block work and took the products out. You could reuse them, but there's not a way of actually breaking them down and making them into anything else. I have got the what are they called? Not EPDs. Yeah, it is an EPD, isn't it? With I've got all that documentation on files as well. So if you want any sort of more formal documents to show how they perform, then I can obviously forward that to you as well.
Great. Similarly, we've got a question in from Gok, which is we've got reaction to fire query. So the information on that. So do we I presume that's been updated in recent times?
So all the PIR products, what the key thing is, I think, to take from PIR is it's not a flammable product. Now, once it gets to about 700 or 800 degrees, yes, it will combust. It's a combustible product. It's not a flammable product. Obviously, things are taken into account. You wouldn't use it on a building like where you've got cladding. But this product here, actually, this is a good key point. This product here, because it goes between brick and block, you can use it. We've just done a great big project on a block of flats. You can use it up to 25 meters in height because it's going between brick and block. But otherwise, I don't really understand the fear of using PIR. When fear to me is false evidence appearing real. Now, a lot of people will not use PIR because it's PIR. But what you need to focus on is where it's being used. If that's going under a screed, is there any risk of fire? If that's going between brick and block, is there any risk of fire? Even if it's on a timber frame house. Now, you've got to ask yourself questions. If you're putting it into a timber frame house, what are you more concerned about? The stuff inside the house, the timbers, or the insulation? The insulation is going to be behind the plasterboard anyway, but once again, it's not a flammable product. So I think you just have to think where the product's being used, but there shouldn't be any concern regarding fire. If it's used on a building of multiple occupancy, then let's say you've got a building, let's say you've got one building like this, which is split into 4, flat 1, flat 2, flat 3, flat 4. There'd be a non-combustible fire blanket running the height of the partition wall, and then there'd be cavity barriers again going across at ceiling level. So things would be isolated in that example, but it would never be in direct contact with a flame, going back to the earlier question.
Okay, and we've got two final questions, which if we can answer them in quick succession, that'd be great. One from Phil: do mortar snots have to be removed from the brickwork in the 10 mil cavity?
So typically how you would work, just a good way of practicing, of working, you would get your block, you get your insulation in, and then as and when you put that board down, as I said, all you would do, you'd just tap it, get your you haven't got to be completely removed, but you just get your trowel and you just run it down the back just to knock any mortar snots off. Because it's a 10 mil gap, you might get a few fine bits going down, but it's not going to be an issue. And again, once the builders have worked with, say, once they've laid 5 or 10 bricks, they really just get into a knack of it, and then they start laying the bricks quickly and efficiently. And again, I've worked with plenty of brickies. I've sort of laboured for them, and a good brickie on a good day is going to look on a straight run, is looking to put down say 1,000 bricks, and by using this product, it doesn't slow the laying of bricks. Again, we need to keep the sort of bricklayers happy because they're focusing on what good a job they do of their brick wall, not by what they do of the insulation. And because the product fits in very quickly and efficiently, there's no reason why the product shouldn't be put in correctly. There's no reason why it shouldn't be put in correctly.
Okay, great. And the final one is it true that PIR insulation performance reduces over time?
It's a minimal reduction, but all of this is sort of calculated initially. So if you like, when we look at the lambda values and things, potentially it might be higher than it's actually stated. But over the period of time, the life of the building, it's not going to reduce. It's going to stick to, it's like the 0.022, for example, will be good for the life of the product.
Great. Thank you for that. Thank you, John, for coming along today and doing the talk. I'm just going to quickly run over some of the events that we've got scheduled moving forward. We've got in June, we've got AI Hybrid Craft, the evolution of architectural medium. That's on the 21st of June. All of this information will be shared on our Eventbrite page and also shared out via emails. So please do keep an eye out for those. It'd be great to see you at all of these events. We've got an event which is being done by CIAT, qualifying as Chartered Architectural Technologist in July. For the August and September events, we're currently finalizing as we have a few options. October, we've got protecting the physical and digital engineered world. This is from the CPNI. That will be a live only event, so no recording will be made available and no slides will be shared. In November, we've got inclusive design, which is on the 15th of November, which should be a really interesting one from a published author. And then December, we've got technical considerations when designing with brick from Wienerberger. Again, in that instance, there'll be no recording allowed, so live only event. So we've got a couple, we've already had one, which was a live only event, and we've got two coming up, which are live only events. So please do bear that in mind. In some instances, we're not able to share slides or actually record the event, so it's only attend only event. Thank you again, everyone, for attending. If you guys do have any suggestions for any future events, please do get in touch with us directly. Thank you again, John, for doing the presentation today. He will be sharing the slides with us, and everyone who's registered on Eventbrite will be sent those out. However, if you'd like to, obviously, please do contact John directly. He'll be able to share slides, information regarding Recticel specifications and general queries, etc. And also, if you'd like a certificate from him, he can obviously make that available. There we go. So thanks for that. We're going to stop the recording.